just present data visualization techniques and tools. You have huge volumes of data. By the end of the day, my role is, my duty is, I have to tell a story, a 3-minute story. I have to show a picture, I have to show a graph. From that, I must be able to derive some valuable insights. This is the purpose of data visualization. When we say data analytics, there are different types of analytics. I am not going into that. You might be knowing that prescriptive analytics, diagnostic analytics, predictive analytics. Okay, these are the different kinds of analytics we say. Prescriptive, how you can describe something. Diagnostic, why poor attendance. Predictive, if we conduct this kind of workshop next year also, what is the attendance we can expect. So this is all about different kinds of analytics we do. I am not going into that also. The end point is, when you are given huge volumes of data, I must be able to tell a story from that data. Okay, this is the objective. You see, data mining, when we teach data mining, in the first chapter itself, we will see a data mining life cycle, where at the top you will see, we are going to give some presentation. From that presentation, my purpose is to extract the knowledge. We call it as KDD, knowledge discovery from data, right? So can you just give any very quick examples, where do you see this kind of graphics, visuals in everyday life? Are we seeing? Everywhere we see, right? When you walk in the corridors of the university, during NAC, we have made several boards where there is a statistical information. We are, instead of numbers, we just show it as a picture so that it can be you can get it easily, right? So we'll start our presentation so that we can quickly go. Conveners are not here. By what time I have to conclude? It's 3:30. 4:15, right? 4:15 we shall close. Next. This is, as I told you, you don't need much attention also. You can. Yes. This is the Hindu paper, today's newspaper. If you see the left side figure, there is a column called data point. Not every day, but in a week, 2 or 3 days, you will watch a beautiful data analysis report, result in the Hindu newspaper. I have just put 2 as sample. See the left side figure, it is the data from the years 1952 to 2022. Nearly 50 years of data, and the states, this is all June months, the temperature of June month. This is how it is present. And the right side figure, can you see, is it, the text is visible? Yes, right side figure, if you can see, that is, at the top you see urban India, at the bottom you see rural India, and you can see how it is different color shades were used. Map 1 is the chart shows the state-wise prevalence of diabetes in urban and rural areas. From the 2 figures, what insights you can make, what story you can tell, you can easily tell that the rural India is in a safe zone. There are some states in green, whereas in urban India, so many states are shaded in red. They are in danger zone. How can you know? We were given a scale 0 to 4.9, green, it is okay. Next orange, thick colors, and then red greater than 10%, like that it was given. As I told you, this figure everyone is familiar with. At the top we see the presentation, the patterns, some graphs, pictures from which we need to derive the insights. So what is data visualization? We use pictures to represent data and process of turning information into pictures for a specific purpose. The purpose of this is important. The purpose of visualization is insight, not just a picture. If we are not able to derive any insights from that picture, it is of no use. Because research scholars are here, students who are studying data mining, data science subjects, you will be drawing many graphs. From that graph, you must be able to give some meaningful beautiful, useful insights. Let me say, for example, we have some logos on the screen. From those logos, we must be able to give some insights. So, Nanda University logo, if we see that, we must get something about Nanda University, some insights about university. So, Horticulture University logo, immediately by seeing that, you get some insights from it, right? So, this is the objective of visualization, not just a picture. You must be able to give some insights. So, why do we visualize data? We know that there is something called as picture superiority effect. A picture is worth, it is the earlier usage. Now I say a picture is worth 1 million data values or 10,000 data values. Instead of showing huge data, you show a picture, you can get what is there. You can understand that. If you say a circle, only 10% can read it. But if you show a picture, people can understand it better. That is what we do for kindergarten children. So why do we visualize data? See the big picture. There are two data, domestic international sales in different months. But from that data, I am not able to get anything immediately. But when I draw a line graph for the same, if I can see that, I'll get something very immediately. So what I can say, that blue is for, green is for international, so domestic, their sales is far above than the domestic category. You might have noticed this was circulated in WhatsApp last year when India-Pakistan T20 match was going on, October 23, 2022. So this is UPI transactions, how they were affected because of India-Pakistan T20 match. High Diwali shopping rush in the morning because match was not yet started. You see the timings on the x-axis. So 1 o'clock match was started, Pakistan batting has started. How the UPI transactions, they have come down. Again, India batting, they have come even deeper, even more down. Then Diwali shopping match was over, India has won the match, Diwali shopping has resumed. So instead of showing some numbers, if I can show with this kind of pictures, you can well convey to the stakeholders, users. So some definitions like the ability to take data, you must be able to understand it, process it, extract value from it. So from the data, value must be extracted, visualize it, communicate it. It's going to be a hugely important skill in the next decades. And then another important trending, not a trending, it was there, storytelling with data, as I have been telling. You must be able to tell some interesting story. Suppose you are working in an organization, you are working in Reliance, you are working in data best price, you must be able to tell your manager some interesting story by the end of the evening about your, so that they can take some strategic decision that will help in the improvement of the business, progress of the business. This is an interesting example. You can see here 4 sets of data. I think even my students can understand these topics. You see here 4 sets of data, x1, y1, x2, y2, x3, y3, all 4 different sets of data. What we do when any data numerical values are given, if we want to derive some insights, generally the first step we do is, we go for measures of central tendency. Measures of central tendency means mean, median, mode. If we cannot get any insights from mean, median, mode, then we go for measures of dispersion, standard deviation, variance, range like this. So, see from this data what we can see. Surprisingly, for these 4 pieces of data, you find some the same, 99, 99, 99, 99, 82, 82, 82, the same. Average is also the same, measures of central tendency are the same. When you see standard deviation, it is also the same. So what we have to do, what we can do, I am not able to conclude anything from these statistical measures. So this is not my example, this is Anscombe, this is called as Anscombe's quartet. It is already there in the internet, online, established one. So now I will try to visualize it, see the difference. All 4 sets of data are not at all related to each other. The first set you can see it is like a linear line, and the second one you find a curvature, third one it is perfectly linear, and fourth one again it is something like parallel to y-axis with an outlier, 4 different sets of lines. So what we can say, the importance of visualization, okay, what we can derive from visuals. So this is storytelling with data. Understanding the context, what is the problem you are dealing with is more important. Choose an effective visual. Clutter has to be eliminated. You have to make sure that you draw the attention of the user to a single point upon which you want him to focus attention and tell a story finally. We will see some visualization principles when we draw a table, when we use a table. So, yes, use light borders or white space to set apart elements. Data should stand out, not the borders. But you see, Indian style of doing slides, our style of doing slides, we use many colors. We dump the slides with so many colors, right? But actually, when you go through visualization principles, it is not the right way to do. So data should be standing out, not the borders. We give many colorful borders, okay? We make it more colorful, but it is not the right thing. So heat map is something that gives life to data. You see to the left, there is data with some percentages, some categories, ABC is there. What I want from that, what I want to derive from that. But when you the same table, when represented as a heat map, I can easily get that. So what I did in the heat map, one color, some light blue to light gray to, I have the shades were changed up to thick color. And now immediately I can focus my attention to 58%, then 55, then 49. Easily I'm able to focus the attention of the user. So if I have a smaller data values like this, I can go for heat map. But if I have larger number of values, so then I have to go for different kinds of graphs. I can go for a point graph, line graph, bar graph, area graph. So many kinds of graphs are there. You can create your own kind of graph and you can give your name for it also, right? So many kinds of graphs are evolving to show the data in a convenient, elegant and attractive way. You know them, these are scatter plots. Two variables we see, x and y. We say positive, negative and no correlation we say. Scatter plots, there are only two variables. What if I want to go for third variable? For the same scatter plot, x and y, if I want to go for I want to show third dimension also. What I can do? I can go for colors. So total bill on x-axis. What is that on y-axis? I'm not able to. Total bill 2, 4, 6, 10. Smokers. Tip. That is tip amount, right? Something like that. So as total bill increases, tip amount also increases or not. And I want to two categories. Third variable is whether that person is a smoker or not. Whether that influences the total bill or not. Okay, so this kind of trivariate analysis, with just change of color, I am able to map how many variables in this graph. Hope you are getting it. 3 variables, right? Earlier it was 2, now it was 3. Can anyone say what if I want to go for fourth variable? Another color? Okay. Another color, it will be like in the same, cannot say. Another color means smoker, yes, no, cannot say. It will not be another dimension. If I want to go for fourth dimension, you can listen by having tea, no problem. Fourth dimension, how can we have it? I can change the size of that dot, right? So it shows the fourth dimension. So now x-axis, of course this is another example. I didn't take the same example. Now colors are changed, colors are there. In addition to that, I'm introducing size of that. Okay, I'm adding fourth dimension to the same graph. Got it? So product, number, price, market share, ABC are the products, and the size, x-axis, market share. Okay, so size might be representing number, price, and then market share. Okay, 4 dimensions are shown in the graph. So line graphs, as we have seen, line graphs. Here the point we have to remember is to show the change of trend over time. So we need to choose a suitable graph. Which graph is suitable? Line graph or bar graph or histogram or so many kinds of graphs are there. We must know first which kind of graph is suitable for which kind of problem. We are going to select the line graph when we want to show change of trend over time. So in a line graph, you can show a single series or two series or multiple series. What is something distinct here? I am focusing my attention on it. Even in 4 lines are there, I am focusing my attention on, I want the customer, I want you to focus your attention on A. Right? So this is how I can make A stand out from other series. Slope graphs, of course, we don't use them much. You can just see how a slope graph will be. Employee feedback over time. So career development, that is the only feature where it has come down, all others have gone up. So that line I am just highlighting it there. So bar charts, they are generally for categorical data. So frequencies, so in the hall how many men are there, how many women are there, I can show it by means of a bar chart. That is as simple as that. In the bar chart, when we draw a bar chart, we should remember the point that they should have a zero baseline. Otherwise, the chart may be misleading. These are the vertical bar charts. Single series you can draw 2 series or multiple series. These are all horizontal bar charts, the same ones. Histogram, yes, hope you understood what is a bar chart. We show the frequency. Whereas coming to histogram, the purpose is to show the distribution of data, how the data is distributed. When you give histogram, I can show some examples also. In Excel we can do Tableau, BI desktop, Power BI. When you show histogram, yes, on the left you see how the data is distributed. Grades on the quiz, nearly 12 students have got or in the pin or in the range 40 to 50, 50 to 60, how many students are there? 22 students are there, 60 to 70. That means your whole data, your marks data is divided into some ranges automatically, and the student falls into which range, that frequency will be mapped onto the whiteboard. Here I want to show you something. When there is huge volume of data, this is called as Galton board. When there is huge volume of data, that's it. What you can understand from this? When the data is huge, right, it comes down to normal distribution. There will be no positive skew or negative skew. Histograms are to understand whether there is positive or negative skew for data distribution, right? If you are dealing with a data set where there are 10,000 records, automatically it will be a normal distribution. So that is the principle we understand from this Galton board. And when we say histogram, everyone should know what is normal distribution. So in between we say mean, and 68% of your data items will be in between plus or minus 1 standard deviation, because all of you know standard deviation and all. 95% of data will be between plus or minus 2 standard deviations, and 99.7% of data will be between plus 3 standard deviation and minus 3 standard deviation. Then what are outliers here? How can you find outliers from the histogram? Is there any way? Hypothesis. What hypothesis you are going to make? How can we find outliers from this histogram? Okay, both things. Thank you. How can we, so in between after 2 standard deviations, after that, we can consider them as outliers, right? This is the general principle we follow. Just before 3 sigma, not 3 standard deviations, just before that value, all values can be treated as outliers. And the other way of finding outliers, because almost all students or research scholars are working with data science projects, they might be knowing what is a box plot. Box plot is basically to find outliers, and when you say box plot, we must know the formulas. Q3 plus 1.5 into IQR, Q1 minus 1.5 into IQR less than that and greater than that will be treated as outliers. So this is the outlier. So second value Q1, Q2, Q3. I made my students do some problems also in the class when I am teaching data mining. So from that we be able to do that. So this is one way of identifying outliers easily through pictures, and the other way is histogram also, you can find the outliers. So pie charts are recommended not to be used. Why? Because you may not be able to represent correctly the area of the part, that area. Why here? See here a pie chart, and at the right what you see? A horizontal bar chart. Which one from which chart you are able to get the insight very quickly? From the bar chart. You can say that supplier A has higher market share, whereas in that figure, though different shades are used, both A and B seem to be almost similar. Right? That is the reason. Again, another example, C, D both seem to be similar in the pie chart, but from the bar chart we can easily identify that C is bigger than D. And when we draw any graphs, these are the pre-attentive attributes that we have to keep in mind. We have to use bolds, italics, colors, size, separate spatially, outline, underline. Attentively we have to use them. So this we call them. You want to focus the attention of your customer on the third line. That is the reason you have changed the length. And then width, orientation, curvature, size, shape, added marks, enclosure. These are all pre-attentive attributes we call them. There are many other attributes also like this. I want to make you focus on 3. So I made the digit 3 as bold. So there are some principles that we study in visualization. These are the principles of visualization. Simplicity, similarity, continuity. I'll just go through it. This is simple. Regional cells. No grid lines, no x-axis, no y-axis. Just a bar, just bars. Their naming. Again it is mentioned not. Okay, it is wrong. So some numbers. That's it. This is the important principle of visualization. And then similarity. Both are similar. You don't need to use so many colors. Right? You can better to use only single color because all are similar. And the continuity. So instead of showing in an unsorted order, if you can keep them in sorted order, you can easily find out which one is the smallest, which one is the largest. This is law of continuity. Law of focal point. So this point, this bar is to which I want to draw the attention of the customer. So that one has to be highlighted with a separate color. You can do this very conveniently in Tableau, Power BI, data visualization tools. Proximity, which are similar, they have to be placed together. In the first figure is north, south, east, west, all of north related bars are placed together, south and then, and the same way in the left one also. Law of figure ground, most of the times we do this mistake. We have to make sure that foreground objects are important, background objects are less important. So we use all thick colors both for the foreground and the background, or light colors both for the foreground and background. That is the reason the text may not be visible. So when you draw graphs, this is what has to be taken care of. Now, after knowing some principles, now how to refine this visual? There is a visual with some data. So what insight I can get from this visual? What is this given? Time of birth by day of week. On the x-axis it is Monday to Sunday. Timings, different colors, purple, green, red, blue are given as timing 6 p.m. to at what time children were born. In the early morning or in the noon time or in the evenings. So percentage on the y-axis. This is the visual given. Can I make any insights out of it? So what I am going to do is, so many usage of colors, I will try to declutter it so that I can get some useful insights immediately. This is what I have made, converted, refined the same visual into this one. Now I am able to tell that weekend deliveries are more likely to be in the early morning compared to weekdays. On the x-axis, I have removed all that full-length names. I need not write Monday, MOL is sufficient. I have categorized the weekend and the weekday and weekend. And see this, how cluttered it is. and the same visual how it was refined. This is the way how visuals can be refined so that information can be conveyed in a better and easier manner. This seems to be okay for us. What is something wrong in it? It seems to be very fine. So only, what is this? It's a line graph with the two lines, x-axis, y-axis. So ticket volume received and ticket volume processed. But as a visualization expert, I am going to refine this visual. What I am going to do? I remove the background grid lines. Y-axis decimal points are not needed. Jan to December, I need not write the full length name. So ticket volume, again I have to go to the graph and come down and see blue is for received, red is for processed. Okay. So I am going to change all this. I made it very simple. I made it very attractive, better compared to the earlier one. Right? I made all the changes. So though it seems to be simple, but as visualization engineers, experts, we need to follow them. So can we refine the visual? So this data is a pie chart for what? Google Home device commands are recorded like this. The command name and how many times that command was given. Is this understandable? Readable? No. So what I am going to do is, again I refine this visual. Now it has become very easier for me to understand what is there and what that visual is trying to convey to me. Now a small this thing. Can anyone tell what is something not correct in this visual? So how baby boomers describe themselves? Baby boomers means maybe our parent generation, earlier generation people, they say that they are not tech savvy, they are more people savvy, right? So what is something we can identify from this visual? Is it okay? If it is okay, also okay. Oh, don't worry, I will complete in my given time only. Very quickly, students. Okay, if you didn't, no one wants to take any chance. So the percentages are not adding up to 100, right? So 40, 61, 22, 78, 42. So percentages should add up to 100. And when you see the color size and the percentage corresponding to it doesn't seem to be matching perfectly, right? And then why do you need a picture like that? You can go for a better picture. Why a man's stick image like that? And so these are some of the issues. So this is in Fox channel. A bar chart was given like this. Can you spot what is the discrepancy there? Another picture. Can you try? Intervals. What intervals? It is 34, 36, 38, 40, 42, right? No problem on y-axis. See here, where the x-axis is starting? 34. It should be at 0. What happens if it is at 34? How you can show the increase in value? If you take the baseline as 34, it will be, so 34 to 39.6 is maybe 5.6 minus 35 minus 34, 1 by 1. It is the increase in value, it will come up as 460%. If you take the baseline as 0, how you will get it? 39.6 minus 35 by 35, you will get it as 13%. So Hope you understood this. When you draw a bar chart, you have to make sure that the x-axis always starts at 0, otherwise the information might be misleading, right? Just for review, dash, compare data, and for this display data distribution. Which are used to compare data? Bar charts. For data distribution, histograms. Which visual representation makes it easier to identify which investment has greater market share? Option A or option B? Option B. Right. You are all attentive, as I know that you are about to conclude. Yes. So this is an example of an effective visualization or bad and ineffective visualization. It's bad and ineffective. We see a lot of clutter, so many elements messed up in a single diagram. And one principle we see, as I said, the law of simplicity. If you have watched the search engine interface, Google, how it will look like? A plain interface with just a text box to give the search item. That's it. Anything else? Very little information, right? Some Google Doodle, something like that. Nothing else above that. If you see Bing search engine, it is also another search engine, but it will be overloaded with so many things, right? So what is the visualization principle? Google or Bing? Google, right? Google follows the best visualization principle. It looks very simple, and your attention will be immediately focused on that box where you have to give the search query, whereas in Bing you have to search where you have to give the search item. So these are the data visualization tools. I ask my students at least to try Excel, but they are very busy that they can't do. But most of the visualization features, visualization elements, we can practice in Excel. But why, if there is Excel, why Tableau, why Power BI, data visualization tools? Why Python? Python also data visualization is possible. We must be able to know the difference. If data visualization in Matplotlib, ggplot, Seaborn, using all those you can draw the pictures, you can draw the graphs. Then why do we need Tableau? Why do we need Power BI? Every language, every platform has its own set of features. So first we must know what is my requirement, what are my requirements, what are the features it provides, which one best suits my requirements. Suppose you take Excel. You don't have very rich pre-processing commands and all, right? So you cannot do NLP. Python, it is different. You can do NLP, morning we have listened, you can do ANN, you can do RNN, you can do CNN. In addition to that, you can go for graphs also, right? So whereas in Excel, you can generate the graphs, but again Excel has a limitation. What is the maybe number of rows is? I think it is 1 million. After 1 million rows, it will not take data, right? But whereas as research scholars, students who are working with real-time data sets, the data set might be of very huge size, so Excel may not be suited in all cases. And you don't have very rich set of features in Excel that are there in Tableau. Tableau is very rich when compared to the set of features. Power BI is very rich, right? So these features we must understand what are there and how we can use them, and which is best suited for my project. Tableau student, how many students have installed Tableau student? Tableau student license is free for 1 year. The thing is, you have to give university name will be there, it will be identified. If you say Adikavi, it will be identified and it will be loaded. Your ID card, you have to upload it after, and you will get a key. It is not like Hadoop installation. Those who have not had faculty, those who have not had taught Tableau or Power BI to their students, it is just like very, wizard type installation. Next, done. Tableau the same way, Power BI is also the same way. Power BI, if you have Microsoft account, you can install and you can start using it. Just drag and drop interface. You connect to a data source, drop it there. Tableau also, connect to a data source, drop it there. Whatever kind of chart you want, you can generate it. Okay, just for, yes, we have 8 more minutes. In that 8 minutes, I'll show you few examples.